Hey guys, I'm going to do 9-6. This whole section is about the inverse trig ratios. I'm trying to do the camera closer, so we'll see what happens. Inverse trig ratios, we use this to find the angles when we know the sides. Inverse used to find angles, they're measurements, right? The angle measurements. When the side lengths are known. Okay? And I'll show you what I mean. But we're using it to find the angles. Let's do a story problem real quick. A ladder is 24 feet long. You lean it against the outside of your house. Here's our house. Okay, we're gonna, here's our ground. We're gonna lean a ladder against it. Okay, the ladder is 24 feet long. So that is referring to the length of the hypotenuse. You guys can see a right triangle right here. We're zooming. Okay, when we do the height, it's going to be the right angle will be the height of like the side of the building with the ground. Okay, you're going to clean out your gutters. You place the bottom of the ladder 4.5 feet from the house. So this distance right here is 4.5 feet. Okay? And then it says how high up do you go, right? X, do you guys see it? And draw it bigger. 24 feet long, 4.5 feet, and then X. You guys go ahead and finish that. Use your Pythagorean theorem. You could do that one. Okay? Now let's talk about this. Triangle dog. I'm going to use a Pythagorean triple because it's easy. 3, 4, and 5. 5 is along the side. It has to be the hypotenuse. So on this, when I do this, I know that the tangent of D is equal to opposite leg over hypotenuse. Let's write those real quick. Tangent of an angle equals opposite leg over hypotenuse. Sine of an angle equals, tangent leg over adjacent leg. Sorry, you guys, right here. That's a big deal. Tangent is equal to opposite leg over adjacent leg. Sine is equal to opposite leg over hypotenuse. And then cosine is equal to adjacent leg over hypotenuse. These are 3 trig functions. These are what we're going to do, the inverse trig functions. Okay, so let's start with what we know. We know that the tangent of angle D is equal to opposite leg over adjacent leg, right? Opposite leg over adjacent leg, 3 over 4. That's what the tangent of D is equal to. Now the question is, what does angle D have to equal so that the ratio of the sides is 3 over 4? In any right triangle, if the ratio is 3 to 4, this angle is always going to be the same for every right triangle. Okay? So we're in my head I'm going, what must angle D equal if the ratio of the sides, right, is equal to 3 to 4? That's what we're saying. What must D equal if the ratio is 3 to 4? So we got to work backwards to find what angle D is, to find the measurement of angle D. So instead of writing it like this, we're going to use, this is the tangent. The tangent of this angle equals 3 over 4. If I want to find what the angle equals, and I work backwards, we go the inverse tangent, tan -1 of 3/4. That's what equals the measure of angle D. That's how I find it, what that angle is. So this is kind of weird. I'll show you. We'll practice, and then we'll practice enough so it becomes easy and not weird. Okay? If I hit second, and then I hit the tangent button. See above the word tangent on your calculator? above the word tangent, you've got tan negative 1. So when you hit the second, it makes it do this blue function, right? So I'm going to clear it. I'm going to hit second, and then I'm going to hit tangent, and I've got the tangent negative 1. So now I'm going to type in what is my ratio. My ratio is 3 divided by 4. This is what the ratio of the sides equals. Close it out. And if I hit equals, it's going to tell me the measurement of the angle. So the angle comes out to be 36.8. Let's round off to the hundredths, 7. 36.87. So measure of angle D has to equal 36.87. Okay? Now, just for schnicks, so this here, this angle is 36.87. If I go, watch, I'm going to show you. This is just kind of for fun so you guys see. If I go 180 degrees in a triangle, 180 degrees in a triangle, I subtract the 90 that I used up on this angle, right? I subtract this 90. Now I'm going to subtract also this 36.87. So this angle up here has to be, if I did everything right, this angle has to be 53.13. That's what this angle has to be. It has to be 53.13 degrees. Well, let's see. Let's go, okay, if the tangent of D is equal to this over this, let's see what the tangent of O is, if I could get it. So we're going to go the tangent of angle O, from O, the opposite, right, go straight across to the opposite leg would be 4 over 3. So if I take, go backwards, if I take the inverse tangent of 4/3, I'm working backwards. What is the angle if the ratio was 4/3? So I'm going to clear it. Second tangent, right? This time I'm going 4 divided by 3. And the angle came out to be 53.13. So you could use either the tangent of O and get this angle, or you could do the tangent of D and get this angle, but they're always going to add up to 180 if you do it all right, right? That'll come in later. Okay, so I want you guys, I guess I could have done one here and one there, huh? Okay, let's do this. Inverse sine. So this is what it always is. If I go, here's the tangent of the ratio that's inside here, the inverse tangent of the ratio of the sides. And in this case, I know it's opposite leg, right, over adjacent leg. If I do the inverse tangent, that's going to give me the measure of the angle. Okay, that's what that means. If I take the inverse tangent of the ratio, that will give me the measure of the angle. Let's try that. Okay, inverse sine. So this time, let's do my DOG again. Let's do it over here. DOG. Okay, let's still do the same thing. 3, 4, 5. Now I know what the angles have to come out to be, 36.87 and 53.13, but let's do it a different way. Let's take the sine of D, which is, right, opposite leg over hypotenuse. So the sine of D is equal to 3 over 5. So we're going to say, if we know the ratio of the opposite leg to hypotenuse is 3 to 5, what would the angle have to be? Well, we know already this angle has to be 36.87, but let's see if it works with the sine. So this time, instead of the sine of D, the sine of the angle has this ratio. We're going to go, what is the inverse function of 3/5? That's what we're going to do, okay? So let's do the same thing. Whoops, here, over here. Clear it. Let's go sine -1 of 3/5. 3 divided by 5, that's my ratio. You really don't have to put the parentheses. Equals 36.87, which is what we said, right? We did it the tangent way, we got 36.7. We did it the sine way, we got 36.87. So that means that angle D, right, when I did that, that means the measure of angle D, I'm going backwards. This angle right here, if I'm going to have this ratio, this angle has to be 36.87. Okay? So when we say this, like here, what is the inverse tangent? That's what we're saying of, and whatever we have in there. Okay? What is the inverse tangent of, so this case, if I'm doing 3, like this one, what is the inverse sine of 3/5? On this one, what's the inverse tangent? Oops, I'm not showing you. This one here would be, what is the inverse sine of 3/5? That's what we're doing. Inverse sine of 3/5. Okay, this one here, inverse tangent. Oh, I don't know if this is going to work. I was asked to make this closer. This one, what is the inverse tangent of, if I'm doing this one, of 3/4? That means, what is the angle if, right, the ratio is 3 to 4. If O opposite leg to adjacent leg equals 3 to 4. That's what this is saying. What is the inverse tangent of 3/4? That means, what is the angle if opposite leg to adjacent leg is 3/4? Okay, let's try another. We're going to do practice, you know. So in this one, when you do sine, you're still taking the ratio, right, of opposite leg to hypotenuse. And if you do the inverse sine of it, that will give you the measure of the angle. If you do the inverse tangent of opposite leg to adjacent leg, that will give you the measure of the angle. Here we go. If we do inverse cosine of the ratio of adjacent leg to hypotenuse, that'll give us the measure of the angle D. Okay. Let's do something different. Okay, let's just make up something. So let's go 7 to 10. And then, I don't really need that one. Let's go 7 to 10 this way. Okay, we go 7. Oh my gosh. I'm sorry, you guys. Okay, let's start that one over. Okay, I'm going to start over. Sorry. Okay, make it look good. We're going to use cosine of angle D. So I'm going to go 13 here, and let's say this is 18. Okay? Just different numbers. If I know the cosine of angle D, I don't usually put the angle, I'm doing it just to help us see it, is equal to adjacent leg to hypotenuse, 13 to 18, then what would measure of angle D have to equal? So we're going to go, what is the measure of the angle? So what is the inverse cosine of 13 over 18? That will give us the measure of angle D. So let's try it. What would angle D have to be? So inverse second cosine 13 divided by 18 equals, so that means angle D would have to be 43.76 degrees. That's how many degrees, okay? That's how many degrees that the angle D would have to be in order to have that ratio. Okay, now we're going to try some work together. Let's see. down here. Let's just do a little bit of practice, and then we'll go back to the other side. Okay. It says A, B, and C are acute angles. That's all we're saying. Rewrite the equation using the inverse trig function. Use your calculator to approximate, because we got to round off. All these answers are going to be irrational. And we're going to go to the nearest tenth. That means 1 decimal place. I want to go, what is the measure of angle A? What does the angle have to equal if the ratio is 3 to 4, which is 0.75? So we're going backwards, right? So we're going to go tangent -1 of 0.75. That's what we're doing. Okay, clear? So we go second tangent 0.75, okay? And that has to be, we knew from the problems we did before, this is our first example. This has to, the measure of the angle has to be 36.87. 36, oh, we said one place, 0.9 degrees. That angle will always give me a ratio of 0.75. Okay? You're going to do the same thing for all of these. Let's keep going. This one's kind of weird, okay? It's a good question, it's just kind of weird. Use this diagram to figure this. Okay. Which of the two acute angles has this ratio? The sine of the angle is 12 over 13. Sine means opposite leg over hypotenuse. Which of angles, remember it has to be of the acute angles, is it going to be F or E? D is out of the picture because it's equal to 90 degrees. I'm not using D. So which angle, F, does F have opposite leg of 12 and hypotenuse 13? Or does E have opposite leg 12 and hypotenuse 13? So I'm going with the E. E, if I circle my E, opposite leg and hypotenuse. That would give me my 12 to 13. So this is angle E. Okay? You guys do that. You can finish that. Now we've got two things left. We have to solve triangles if you know two sides. Look at two sides, two sides. Two sides, two sides, two sides, two sides. We know, or we have one angle and one side. One angle, one side. One angle and one side. Okay, we're going to learn what that means, and we're going to do it right now. Okay. So on this one, you want to, whenever we say solve a right triangle, that means find all the missing angles, find all, all the missing sides. Okay, you got to calculate them. So you got to find every side, every angle. You need to know all the angles, all the sides. So in this one, we could do the first one easy. Look, we got to know what this side is. We know two sides. What's the third side? We can use a trig function, or we can use Pythagorean theorem. So I'm going to use Pythagorean theorem. You guys could use trig also, right? Pythagorean theorem says I have to know hypotenuse squared equals leg squared plus leg squared. So this is H. The box points to the legs, L, L. So this is my C squared equals 3 squared plus 4 squared, right? C squared equals 9 plus 16. C squared equals 25. So C equals 5. That doesn't seem right. 9 and 16. Oh, it's because I wrote it wrong. Should be 3, 2. This should be a 2. I did 3 and 4. Changes. Okay. Should be 3 squared and 2 squared. So I get 9 plus a 4, 13. So C has to be the square root of 13. Okay? So we'll clear this out. I'm going to go second x squared button, write it down here, and I'm hitting 13 equals, so this side is 3.6 long. So C is equal to 3.6. Now, I have to find an angle. So I'm going to erase this in here because I'm going to do different stuff. All this. I need a good eraser. Okay. So C is 3.6. Let's find, what do you want to do? Let's find measure of angle B. It doesn't really matter. So what's a measure of angle B? Measure of angle B. I can use opposite leg, okay? And then this would be my adjacent leg. So if I'm going to do opposite leg and adjacent leg, I'm going to do tangent. You guys don't have to do it this way. You could go from A and do opposite leg, adjacent leg. You can use the hypotenuse and do sine or cosine. I'm not, only because this is a rounded number, it'll be less accurate, or what if I did this wrong? So I'm going to use tangent, and I'm going to say the tangent of angle B, okay? So tangent of B equals 2 to 3. Got it? Now we're going to go backwards. We're doing it. I know the ratio. I want to find the angle. So I'm going to go inverse tangent of 2/3 will equal my angle B. Okay? Inverse tangent of 2/3. Clear? So I'm going to do second tangent 2/3, and I got 33.7. So measure of angle B has to be 33.7. Okay, we're going to hook all this together. So that's measure of angle B. Let's erase this, make it look good. You just need a better eraser. I got a junky eraser. I hope you guys have a good one. Now, I've got this, so I knew 3, I knew 2, I know 3.6, that's the length of this side. Now I've got this angle here is 33.7 degrees. Okay? So first I found the sides, and I used Pythagorean theorem. You could do different ways if you want. Second, I used a trig ratio, okay, to find one angle, one acute angle. Well, and I don't even have to say acute. This is 90, so this has to be acute. Okay, now, number 3, we could just use the fact that your golden rule is 180, right? So if I go 180 minus the 90 minus 33.7, what am I going to have left over for angle A? So let's punch it in and see. I'm going to go 180 minus 90 minus 33.7. So this angle A has to be 56.3. So measure of angle A equals 56.3. So I've got everything then. I've got the length of this side was given. The length of this side was given. The length of this side I calculated with Pythagorean theorem. This angle, B, I calculated using the tangent, and then I subtracted from 180 the two known angles to find the last angle. So then subtract, oh man, hold on. Subtract angle measurements from 180. And there's your steps, okay? How about we put it over here? So we're going to use Pythagorean theorem. I'm going to rewrite it neater, okay? To find the missing side, right? We're going to use use a trig ratio. We're using the inverse, right? To find one angle. And then we're going to use 180 minus 90 minus that angle from this part here for the third angle. 1, 2, 3. Okay, now let's do last problem. Here we go. This time we're going to solve a right triangle. This one we knew, you know, what do we have? We knew two sides, right? Okay, on that one we know two sides. This time we're going to say you know one side and one angle. Okay, one side and one angle. Okay, let's see what we got. We could go use our trig ratio, and you guys could do these different ways. So if I, let's say that I'm just good with tangent, and I would want to go tangent of 19 equals 20 over x, right? If I did if I did sine of 19, I go 20 over, okay, the hypotenuse. So first let's label this. Okay, box points to the legs. This is a leg. This is a leg. This is my hypotenuse, right? I'm going 19 to the 20. So this from 19, this is my opposite leg. So when I do this, I can go, if I'm using opposite leg, I can go opposite leg over my adjacent leg and use tangent, or I could use sine opposite leg over hypotenuse, either one. And I'm going to use tangent, okay? So first thing we're going to do, number one, we got to label, right? We got to do the labeling, all the stuff we did before, but we're going to use a trig ratio to find another side, a second side. We're going to find a second side length, okay? So I'm going to go tangent, if I'm going to do opposite leg over adjacent leg, right? Opposite leg, adjacent leg. We'll put an X right here, okay? Tangent of 19 degrees equals 20 over X. Multiply both sides by X, so X times the tangent of 19 equals a 20. Divide both sides by 19. X equals 20 divided by the tangent of 19. So let's do that on our calculator. 20 divided by tangent 19 equals 58 length. Okay? So if this is 19, this is 20, this side here would have to be 58.1. That's this length. Okay, so I've got two lengths. I need a third length here, right? And then look at it. I've got a 90 degree angle, right? I've got a 19 degree angle. We could just subtract from 180 the two angles to find the third angle. I'm going to do that. That's easy. Number two, subtract 180 minus the two given angles to find the third angle. Okay, let's try it. So I'm going to go 180 minus this 90, I'm using up the 90, minus the 19, using up the 19 more degrees, I got 71. So this angle has to be 71 degrees. So I've got angle, 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 got all my angles, right? I've got side, side, I need this side here. Now if we want, we could use Pythagorean theorem, or you can use tangent, use like a different one. Use cosine, use sine, use tangent, use whatever one you want. So number three, whichever one will work, you're going to use Pythagorean theorem, or a trig ratio to find the last side. Okay, I'm just going to do Pythagorean theorem. So Pythagorean theorem, h squared equals L squared plus L squared. H is what I'm trying to find. 58.1 is one of the sides plus 20 squared, right? So let's do it. 22 times 2 is 400. 58.1, don't know. Squared. This is, woo, 3375.6. Okay, we're going to add this. Notice the h squared is already isolated, so we just add these together. $3,775.61 is h squared. Now I have to take the square root of that. Second square root, I don't know how to make it do that. 3,775.61 equals, so the last side is 61.4 log. Let's see if that makes sense. This side is 61.4, 20, and 58. That makes sense. And I've got triangles 19, 71, and 90. And I could double check and go, this square plus this square, does it equal that squared? This, and this, do they add up to 90? Okay, so these are hard. Hard. Okay, this section's the hardest one. You're pulling everything together. Here's what we did. You guys only have 6 hard problems. That's it. So on this is 21. Okay, so some of this you already know. FE is 21. D to F is 20. Angle F, oh, I didn't put that one on there. So you could use Pythagorean theorem to find this side, right? You're following this. 2 sides are given. If 2 sides are given, use your Pythagorean theorem. And then if we want to do the tangent of E to get measure of angle E, and then subtract 180 minus this, and then it'll give you measure of angle D. Okay, you guys try. You got the steps. Good luck. I hope you do well. See you in class. I'll help you. Bye.